24 mind-blowing pictures of space taken by James Webb Space Telescope. On July 12, 2022, NASA's James Webb Telescope released its first picture after spending 30 years in development and launching on December 25, 2021. The highly anticipated telescope is located around 1 million miles from Earth, at a point which is known as the second Lagrange point, or L2. Known as the Webb or JWST. Here are 24 pictures to celebrate 24 months of the James Webb Telescope releasing pictures. Chameleon Eye Dark Molecular Cloud. Around 630 light-years away sits the Chameleon Eye Dark Molecular Cloud. This cloud is so cold and dark that molecules, not just water, have actually frozen onto the grains of dust inside the cloud and proves that more complex molecules could form in the icy depths of molecular clouds before stars are born. These frozen molecules, like carbon dioxide, ammonia, and methane, could go on to become building blocks of life.
The heart of the Phantom Galaxy. The Phantom Galaxy, also known as M74, is a particular class of spiral galaxy known as a grand design spiral, meaning that its spiral arms are prominent and well-defined. It is around 32 million light-years away from Earth in the constellation Pisces. This picture reveals the delicate filaments of gas and dust in the spiral arms which wind outwards from the center of this image, where a lack of gas in the nuclear region provides an unobscured view of the nuclear star cluster at the galaxy's center. The heart of the Milky Way. Our home galaxy is stunning, and this picture is taken of a region that is around 300 light-years away from the supermassive black hole at the Milky Way's center. This cluster hosts baby stars that glow through the cocoon of a dusty cloud. At the heart of the cluster is a still-forming star over 30 times the mass of our Sun. Ringed Uranus. Bringing it much closer to home, the Webb has shown Uranus in further detail than ever seen before, including the planet's seasonal north polar cap, as well as bright storms near and below the southern border of the cap. The image also reveals 9 of the planet's 27 moons, which are the blue dots that surround the planet's rings. Picture, NASA/ESA/Webb/CSA. A fingerprint in space. Every 8 years, 2 stars are brought together by their orbits, and create colliding streams of gas that, under the right conditions, form a new ring of dust. In the Webb image, 15 of the 17 rings are seen for the first time. The star pair are known together as Wolf-Rayet 140, WR140, and contains one Wolf-Rayet star. Picture, NASA/ESA/Webb/CSA. Inside the Crab Nebula. The Crab is a remnant of what was once a massive star, but it is unusual in its composition. This makes scientists think that its star might not have been typical either, but the Webb mapped out the light emitted from the dust in the Crab Nebula in high resolution for the first time. In other supernova elements, dust is concentrated at the center, but in the Crab, the dust is found in the outer shell. Free-floating brown dwarfs. In this picture, there are 3 brown dwarfs free-floating, including the tiniest, free-floating brown dwarf ever discovered. Brown dwarfs are celestial objects that are not quite stars but not quite planets. These objects sit around 1,000 light-years away, and are only 5 million years old, but astronomers are not sure how these no-stars-attached small brown dwarfs are even able to form. Rho Ophiuchi. Rho Ophiuchi is the closest star-forming region to Earth, and is a place where many sun-like stars are being born. In this image, there are around 50 young stars, many close in mass to our star, which gives us a glimpse into the early life of our Sun. This picture was released to mark 1 year of the James Webb Space Telescope releasing images of the universe around us, as cosmic dust and gas create new celestial objects. Pillars of Creation. This renowned image reveals the pillars of creation which sit in a small region within the Eagle Nebula, roughly 6,500 light-years away. The mid-infrared light and near-infrared light reveal thousands of nearly formed stars which appear as orange spheres just outside the pillars of dust. The wavy lines that look a little like lava at the edges of some pillars are injections from stars that are still forming within the gas and dust. Supernova remnant Cassiopeia A. For the first time, astronomers have combined data from NASA's Chandra X-ray Observatory and James Webb Space Telescope to study the supernova remnant, which is also known as the green monster. The work helped explain the unusual structure in the debris from the destroyed star. It is thought a blast wave from the exploded star slammed into material surrounding it. The reason why this particular destroyed star is known as the green monster is because of its resemblance to the wall in the left field of Fenway Park in Boston. The remains of a dying star. From dead star to dying, Webb's image of the Ring Nebula reveals the details of the Southern Ring Planetary Nebula, previously unseen to astronomers. The Webb's MIRI instrument provides the sharpest and clearest view of the star, and the possibility that the dying star at its center has a companion. Herbig-Haro 797. The bottom of the image reveals two baby stars spewing out almost parallel jets of gas, which astronomers previously thought was just one star. The string is known as a Herbig-Haro object, which is a bright region that surrounds newborn stars, formed when the star's outflow collides with nearby gas and dust at high speeds. The top half of the image are thought to be two further baby stars, which have been spotted through Webb's infrared vision. The hourglass creation. In the center of this hourglass lies a protostar. The clouds of dust and gas are only visible in infrared light from the Webb. The protostar is a hot, puffy clump of gas that is only a fraction of the mass of our Sun. As it draws in material, the star will compress, get hotter, and then begin nuclear fusion, which will then create a star. In the picture, the blue area is where dust is the thinnest, and oranges are thicker layers. The top of the Horsehead Nebula. Capturing the horse's mane, this image released by Webb reveals how young massive stars can influence the chemistry of nebulae, and this region is one of the best to study how radiation interacts with interstellar matter. This portion of the Horsehead Nebula is around 0.8 light-years across, which provides a little perspective on just how big space truly is. The starburst galaxy Messier 82. Sitting just around 12 million light-years away, in the constellation Ursa Major, is a starburst galaxy. M28 hosts a frenzy of star formation, creating them 10 times faster than the Milky Way galaxy. By showing M82's center in exquisite detail, researchers can distinguish small bright compact sources that could help scientists better understand the different phases of star formation and the timelines for each stage. The Cartwheel Galaxy. This galaxy formed around 4,000 million years ago as a result of a high-speed collision. It is composed of two rings, a bright inner ring and a colorful outer ring. Both expand outwards from the center like shockwaves. But the spokes are caused by glowing, hydrocarbon-rich dust, which are not only seen in the galaxy itself, but in the companion spiral galaxy appearing in the top left of the picture. The Cosmic Tarantula. Thousands of never-seen-before stars are littered across the Tarantula Nebula, but Webb has caught them all. The telescope has revealed the details and composition of the nebula, as well as dozens of background galaxies. The center of this image is hollow due to the radiation from young massive stars, which appear blue, as the nebula produces new stars at a very rapid rate. The Wolf-Lundmark-Melotte Dwarf Galaxy. To really put into perspective how big the universe is, this is only a portion of the irregularly shaped galaxy which is in the constellation Cetus. The image shows countless white stars that are interspersed with yellow and orange background galaxies and shows how the Webb can differentiate between individual stars. The galaxy is around 3 million light-years away. The Orion Nebula. One of the brightest nebulae in the night sky is Messier 42, also known as the Orion Nebula, which is south of Orion's belt. At the heart of the nebulae is the young trapezium cluster of stars which are only around 300,000 years old. These stars are very hot, and the energy they produce causes the gas in the nebula to glow. This picture is a long-wavelength color composite that focuses on the gas, dust and molecules in the region. Barred Spiral Galaxy NGC 1433. Dust is everywhere in space, but Webb manages to pierce right through to show spiral arms that are created from young stars releasing energy. This shows how forming stars influence the larger structure of an entire galaxy. This particular galaxy is a Seyfert galaxy, which are typically close to Earth, and has a supermassive black hole in the middle eating material. Stephan's Quintet. Webb revealed Stephan's Quintet in never-before-seen detail, as the galaxies collide, pull, and stretch each other in a gravitational dance. With this picture, Webb provides a piercing look into how interaction like these could have driven galaxy formation and evolution in the early universe. The Webb used its Miri filter, and the colors red, green, and blue help differentiate the galaxy features from each other. Red is dusty, star-forming regions, blue are stars or star clusters without dust, and green/yellow are regions that are more distant. Spiral Galaxy NGC 7469. Around 90,000 light-years in diameter, this spiral galaxy is located roughly 220 million light-years from Earth, in the constellation Pegasus. The galaxy is very dusty, but Webb's powerful infrared can gaze into its center where it houses an active galactic nucleus, which is a bright center that is dominated by light which falls into the center of the galaxy's black hole. The spikes in the picture are diffraction spikes that are interacting with the telescope mirrors. The Carina Nebula. One of the first images by NASA from Webb is the Carina Nebula, which shows a sneak peek into stars and their earliest rapid stages of formation. Also known as the cosmic cliffs, the image reveals emerging stellar nurseries and individual stars that were previously obscured as objects in the earliest stages were difficult to capture. But thanks to the Webb and infrared, this cosmic landscape has been captured, although the tallest peaks in this image are around 7 light-years high.